If any of the polynomials that you're multiplying are not monomials, then you need to multiply each term of the first polynomial by each term of the second polynomial using the distributive property of multiplication, and then combine any like terms that you have. So our first example here, we're multiplying a monomial by a binomial. So we're going to multiply this monomial times each term of the binomial. So we'll multiply 4x by 4x cubed. And the next term, we'll multiply 4x by 8. And now we have some monomial multiplication. For the first term, we're going to commute and associate. So multiply the numerical factors 4 times 4 and the variable factors x times x cubed. So multiply the same base, add the exponents. 1 plus 3 is 4. In the second term, we're going to multiply the numerical factors. 4 times 8 is 32. And then times the variable factor x to get our product. Our second example, we're multiplying a monomial by a trinomial. So we will start by multiplying negative 5x squared by the first term of the trinomial, 2x squared. Then another term, multiply negative 5x squared by the second term, 7x. And then a last term, we're multiplying negative 5x squared by negative 2. So for the first term in our monomial multiplication, we're going to multiply the numbers. Negative 5 times 2 is negative 10. And the variables, x squared times x squared, we'll add those exponents to get x to the 4th. Then in our second term, we're multiplying negative 5 times 7, that's minus 35. And x squared times x, add the exponents, that's x to the 3rd. For the last term, then, negative 5 times negative 2 is positive 10 times x squared. And that is our product for that multiplication. In the third example here, we've got a binomial times a binomial. So we'll start with the first term of the first binomial, distribute it to each term of the second. So y times y. And another term, y times 7. Now let's distribute the second term of the first binomial. So another term, 5 times y. And another term, 5 times 7. Each term to each term. So let's look at the first term of our product. Y times y, we'll add the exponents, that's y squared. Our second term, y times 7 is 7y's. And 5 times y is 5y's. Last term, 5 times 7 is 35. Now this time, we actually have some like terms that we need to combine to simplify our product. So 7 plus 5 makes 12y's altogether to get our simplified product here. Then our last example, we're distributing each term to each term. So let's start with the first term of the first times each of the second. So 2x times 7x. And another term, 2x times 5. Now let's distribute the second term to each term of the second polynomial. So minus 4 times 7x. And minus 4 times 5. Let's simplify the monomial multiplications we have here. So multiply the number factors. 2 times 7 is 14. X times x, we'll add the exponents to get 2. In the second term, we have to multiply 2 times 5, that's 10 times x. And the third term, negative 4 times 7 is negative 28 times x. And the last term, negative 4 times 5 is negative 20. And we do have like terms that we can combine. So 14x squared, and then 10 minus 28, that's minus 18x's altogether. And minus 20 completes the simplified product of those two binomials. Then another example here, 3x plus 4 squared. Does this look like multiplication to you? Yes, because exponents are repeated multiplication. It says take the base, which is everything in the parentheses, and multiply it by itself, two factors. Okay. So this does become a multiplication here. And I'm going to show you another method for multiplying these polynomials, which is optional, but it's the tabular method. So we're going to multiply 3x plus 4 times 3x plus 4. So if we multiply 3x times 3x for the first tab here, 3 times 3 is 9, and x times x is x squared. If we multiply 3x times 4, then 3 times 4 is a positive 12 times x. If we go and to the next tab here, 3x times 4 is a positive 12x. And for the last one, 4 times 4 is a positive 16. So this is a way to multiply with each term to each term, which also helps us in combining like terms, because you'll notice that these like terms line up right there. So 12 plus 12 makes 24 x's altogether. And for the last problem, I'll show you both methods. So let's just distribute each term of this binomial to each term of the trinomial. So a times a cubed plus a times negative 3a squared plus a times 7. Now let's distribute 2 to each of these terms. So 2 times a cubed plus 2 times negative 3a squared plus 2 times 7. Each term to each term. And then simplify that. So a times a cubed is the product rule, a to the 4th. For the second term, if we multiply, that's a negative 3 for the number factors, and a times a squared is a to the 3rd. Next term, a times 7 is 7a's. Then 2 times a cubed is 2a cubed. Next term, 2 times negative 3 is negative 6 times a squared. And the last term, 2 times 7 is 14. Do we have any like terms? Yes. So we can combine those together. Negative 3 plus 2 is negative 1a cubed. And that ends up being the only like term, so everything else remains. I just put them in descending order. So could we use the tabular method to multiply this? Yeah, we could definitely do that. Let me erase this one and we'll do it over here. Okay, so we've got an a plus 2. And we've got a cubed minus 3a squared plus 7. So let's start with the first tab. A times a cubed is a to the 4th. A cubed times 2 is a positive 2a cubed. Then the next tab, negative 3a squared times a is negative 3a cubed. And 2 times negative 3a squared is negative 6a squared. Then the next tab, 7 times a is positive 7a. And 7 times 2 is positive 14. So we do have like terms here. The other across, those are not like terms. So those are the only like terms. And we'd end up with the same answer that we do when we just distribute each term to each term the long way. Either way is really the same. Just multiply each term to each term and then simplify by combining like terms.